Okay, so in this lesson we're going to look at light-dependent and temperature-dependent resistors. And we're going to look at how to draw diagrams basically of electrical circuits. So we're going to kind of go into this in a little bit of detail. And this whole section of learning, we will be looking at students should be able to design and build simple electronic circuits. That's what we're working towards and building up. Okay, so an LDR, and they're abbreviated LDR, are light-dependent resistors, and it's a resistor that has a resistance value that changes according to the amount of light energy that falls on it. It has a high resistance in the dark, so that very little current will flow through it, and in bright light, the light-dependent resistance has a low resistance, and electrons inside are free to move and carry current. And this is what a light-dependent resistor looks like. So when it's in the dark, so for example, when it can't sense any light in the environment, what it does is it becomes a really high resistor and it stops the flow of electricity moving through the circuit. So essentially what it does is it enables the circuit to be able to sense the environment and sense what's going on. As the light intensity starts to increase, so when you put light onto this, shine light onto this light dependent resistor, it kind of frees up and it starts to allow the electrons to move through it. So it's kind of like it's a sensing device, and it's also like a gate as well. So it controls the flow of electricity through the circuit. So when the light decreases, when the light decreases, resistance increases, and then the opposite way around. When light increases, resistance decreases. And we can plot this on a graph. So for example, you have along the bottom here, you have light intensity. So for example, when you're going from left to right, you're going from very little light to a lot of light. And then here you have resistance. Okay, so you can see that in the dark. So we can see, and this side here measures resistance. So it's going from low resistance up to high resistance. So you can see that in the dark, so in around here, the resistance is high, so it stops the flow of electricity. And then as the light starts to increase, you can see that the resistance starts to decrease. So this will allow the flow of electricity through the circuit. And you can have a setup like this, and we might look at something like this in the lab. You can use a torch and a multimeter to study how the resistance of an LDR varies with light intensity. So what you can do is you can set up a light dependent resistor and you connect it up to a multimeter, and that will measure the resistance. And then you can have a light source, it's attached onto a stand, and what you can do is you can vary the distance of the light in relation to the light dependent resistor. So the closer the light dependent resistor is, the more intense the light is going to be, and therefore the less resistance on the circuit. The further away the light is, the less light is going to hit the sensor, and therefore you're going to get more resistance. So yeah, that will show up on this multimeter. You set it to measure resistance. So if let's kind of look at this from a circuit point of view. So this is our circuit. So we have our battery up here, we have our light source, we have a switch here, and then we have a resistor. So if I close the switch, so the battery is going to push the electrons through the circuit, so you have this flow of electricity. And what you can think about then is you can think about, imagine this is your resistor here. So the resistor basically resists the flow of electricity. At the moment, there's zero resistance. Okay, so there's no resistance on this. Now, if we were to, let's say, we were to put this resistor, imagine then this was a light dependent resistor, and we were to take this and we were to cover it up and put it into the dark. What would happen is that would essentially increase the resistance. So you get this kind of effect that would happen. So you get very little movement of electrons through the circuit. But then as you start to shine light on it, what will happen is the resistance of the resistor will start to decrease, like so. And then what you'll what you'll get is you'll get more movement and more movement of electrons through the circuit. So that's like a light dependent resistor. So then the more light there is, the more there's a flow of electricity through the circuit. So this can be used to allow the circuit to sense the environment and see how much light, for example, is in the environment. So that is a light dependent resistor, and that is how a light dependent resistor works. So the next type of sensor then that we will use and that you look at is one of these guys here, and instead of being sensitive to light, it's sensitive to temperature, so how hot or cold it is in the environment. And this is what's known as a thermal resistor. So a thermal resistor is a resistor that has resistance values that change according to the temperature. So again, it all depends on temperature. And again, this can be used by the circuit to sense the temperature in the environment, and it can control the flow of electricity, electrons, because of that. So it has a high resistance at low temperatures, and very little current will flow through it. And at high temperatures, the thermal resistor has low resistance, and electrons inside are free to move and carry current. So again, we can see this relationship on the graph. So we have, so along the x-axis you have the temperature in degrees Celsius, and then along the y-axis you have resistance in ohms. So you can see there, as the so at cold temperatures, so at 0 degrees, for example, the resistance is high, so therefore there's going to be very little flow of electricity through the circuit. And then as you start to increase or you start to heat up the environment, the resistance on this thermal resistor starts to decrease, and then what's going to happen is it will get down very low, and you'll get then the flow of electricity through this circuit. So again, this is a relationship between temperature and the resistance of these what are called thermal resistors. And this is what they look like. And you can use an ohm meter and a thermometer to investigate how resistance of how the resistance of one of these guys varies with temperature. So we can have a setup like this. So you have like a beaker of water, you have a Bunsen burner or some kind of heat source, and it's all on a stand. And you can use a thermometer. So thermometers are used to measure temperature. And then you can heat up the solution. So you can watch the temperature and how it changes, and then what you can do is you can record you can record, for example, the resistance on this. So what you'll find is that as it starts to get hotter and hotter, as it starts to heat up like this, the recorded resistance on the ohm meter will start to drop down. And basically this is a term, these are used, for example, as thermometers. You can use them in, like for example, kettles and things like that, to control the heating of water. So when water gets to a certain temperature, it can switch off, or it can switch on, whatever way it is that you want to kind of set it up. So these are thermal resistors, and the resistance depends on the temperature that's in the environment. So if we were to go back here to our circuit and we switch on our circuit, so we imagine, so instead of light shining on this resistor here, we imagine that it's temperature. So for example, when the temperature is very cold, there's a lot of resistance on the resistor. Okay, so when it's in a really cold environment, it completely slows down the flow or the current of electricity moving through the circuit. And then as you start to heat up the liquid, what will start to happen is it will reduce the resistor and the resistance, and what that will do is it will allow the electricity to flow. So we're going from cold here to hot, and when it's hot, basically it will allow the flow of electricity through the circuit. So again, what this does is it enables the circuit to be able to sense the environment with these types of resistors. So this is the thermal resistor, and it's thermal meaning temperature, it's used to measure the temperature that's in the environment. It can be used to sense the temperature that's in the environment, and with that, it kind of makes a decision to restrict the flow of current through the circuit. So that is the thermoresistor. So the next thing we're going to look at then is just how to draw these circuits. So if we have a look at this setup here, so we have a battery source, we have a light. Here we have an ammeter that measures current. We know it's an ammeter because it has this A on it. And then we have a switch. And then we have this connecting wires that connects the whole lot together. Now what we can do is we can take this and we can represent it on a diagram like this. So for example, up here we have the battery. So that's representing this. So that's the symbol for the battery. We have the switch, which is the switch here. That's the symbol for the switch. We have this here A, which is the ammeter. That's the symbol for the ammeter. And then here we have the light, and this is the symbol for the light. And the wires then, the lines between it, are the connecting wires that connect up this circuit. So you can see that this enables us to draw these circuits. So we can even draw the circuit before we construct it, and it just makes it easier for us to kind of think about it and look at and think about the circuit. So circuit diagrams make it easier to understand electric circuits. A circuit diagram is a graphical representation of a circuit. So that's what this is. Power supply units or batteries are often drawn on the top of the diagram. So traditionally you draw the power source, for example, on the top. Constructing wires are drawn as straight and horizontal vertical lines. So these are the constructing wires. So you see these lines here. And internationally recognized symbols are used for the components as well. So we have these symbols here which are internationally recognized. So again, science is all about trying to get everybody to use the same symbols when they're talking about, for example, electronic circuits or when they're making measurements. So you need to be able to draw, and you need to be able to draw a circuit like this, and you need to be able to interpret what the circuit would look like how would you draw a circuit, and then how would you, if you're given the drawing of a circuit, how would you construct that circuit. So what I'd encourage you to do is to pause the video, have a look at each of these circuits here, and draw each of these circuits using the symbols. Okay, so give yourself about 5 or 6 minutes, and if you draw each of these circuits. So if we have a look just at the components, so you have the battery, you have a switch, you have an ammeter, and you have a light source. Battery, light source, switch, and ammeter. Here you have a variable resistor, that's what this is, a battery source, a light, and an ammeter. And then up here you have a variable resistor, a battery, a light source, a switch, and an ammeter. Okay, so let's look at constructing these simple circuits. So again, if we take the first one here, so here are all of the circuit symbols or component symbols that you need in order to draw these circuits. So again, traditionally we start by putting the battery up the top. So if we start here, we're going to draw this one here first. So the first thing we have is our battery. So again, we just draw the symbol for the battery. Okay, so the battery has the positive terminal and it has the negative terminal. And then what we can see then is we can see that this is attached to a switch. You have a switch like so. And then what you have down here then is you have your ammeter, which is this one here. And then it is connected then to so a light source, which is this one here. And then it's connected back around to the battery. So it looks kind of something like this. Okay, so that's the, so if we look at these, so the battery, this is the battery here, the switch, this is the switch here, the ammeter, this is the ammeter, and the light source, this is the light source here, and then these wires, these individual wires then are all of these straight lines here, like so. Okay, so that's the first one. So if we have a look at the second one then, so again we start off with the battery. Traditionally you put the battery up here at the top. So we draw our battery. You can abbreviate it like so. So you have the positive terminal and you have the negative terminal. Okay, so that's our battery. Then down here we have our light source. Then that is connected around to, so we have our switch then over here. And then we have our ammeter, like so. So again, you have the components. So if we think about, here's the battery. So this is the battery. Here is the light source. So this is the light source. And these are the symbols over here. This here is the switch. So this is the switch here. And then this here is the ammeter, which is represented by this symbol here. Okay, so that's those guys. Okay, so let's have a look. Let's look at the next one. So the next one is this one here. So again, we have our battery source at the top. Okay, let me just get rid of these guys. Let me just get rid of these so that I can actually. Okay, so I just moved these over here just to make a bit of space. So let's have a look at this one here. How do we construct this graph? So again, we identify the parts that we have. So this is our light dependent resistor, which is this guy here. This is our ammeter, which is this guy here. This is our light source, which is this guy here. And this is our battery, which is this one here. Okay, so let's construct this one. So again, we have our battery. So we have our positive terminal and we have our negative terminal. So again, traditionally we put the battery up the top. We have then, it's connected to a light source, which is like that. So that's that symbol here. Then it is connected to an ammeter, so which is this symbol here, just an A. And then it is connected to a light dependent, or a variable resistor, which is this one here. So a variable resistor is just one that you can change the resistance on it. So again, we just draw the symbol for variable resistor. So it kind of looks something like that with an arrow going through it. And then that is connected up here. Okay, so that's that simple circuit. So this variable resistor here, basically what you do is you can move this back and forth and it increases or decreases the resistance of the resistor. Okay, so that's that one, and then we'll finally look at this one here. So this one is just, it's just a little bit messed up, as in like it's all just twisted over each other. But again, we follow the same kind of guidelines. So what do we have? So we have our positive terminal and our negative terminal in our battery. We have this, which is a light dependent resistor. So we can put this down, put it down here. And it's just something like this that has an arrow through it. And looks like then we have a light source. So we put our light source here. Then it looks like we have an ammeter, which measures the current through the circuit. And then it looks like we have a, I'll just put this up here. we have then a switch. So this enables us to turn on and off the circuit. Okay, so these are our, so we have this here is a switch. So this is our symbol for a switch. We have this here is an ammeter. It's the symbol for the ammeter. We have our bulb. This is the symbol for the bulb. We have this guy here, which is the variable resistor. This is the symbol for the variable resistor. And then we have this guy here, which is a battery, and this is the symbol for the battery. Okay, so they're all the electronic components. So that is just basically being able to draw simple electronic circuits. So again, that's what you need to be able to do. So you need to be able to know, you need to know all of these individual parts and all of the other component symbols that we looked at in previous lessons. And then this is like taking those symbols and drawing circuits like this. So you need to be able to do that. And then you need to be able to interpret the circuits and see like what components you have. So if you're given a diagram like this, you'll be able to take this diagram, take all these components and construct this particular circuit and make sure that it works. So that is light dependent resistors, temperature dependent resistors, and how to draw electronic circuits. Okay, thank you for listening.